If you're watching this video, you're probably exploring or trying to transition into the world of AI engineering, or you're wondering whether it's even relevant anymore. Well, here's the honest answer. You can transition, it's absolutely possible. No, you do not need a computer science degree, but you do need a right roadmap. It's not about those tech jargons, it's not about the salary. It's a clear, realistic path that matches the actual reality and what works in 2026. You need to know what an AI engineer really does to even understand if that's something that you are interested in and you really want to do. Because there's a lot of confusion about what AI engineers actually do. All right, do they train models? Do they build systems? Well, the answer is probably a bit of both. AI engineers build AI-powered systems that work in the real world. These are not research prototypes. It's not just model training. It goes deeper than that. These are full systems, all right, LLM-powered apps, retrieval augmented generation, automation workflows, all right, conversational assistants, and agentic AI systems. These are the things that make business run today. And here's the key difference people miss. Machine learning engineers focus more on models. AI engineers focus on systems. Yes, there are overlaps, but AI engineers actually spend more time on systems. All right, it's about retrieval orchestration, the right chunking techniques, deployments, and guardrails, performance, cost, product integrations. In short, the entire jing bang. While ML engineers make models better, AI engineers make them useful. What you need to know before even delving into learning AI is you do not need academic theory or advanced math, but you do need certain foundations like practical programming, all right? Primarily Python. You should be comfortable reading code, debugging, understanding functions, working with APIs, all right? System intuition, not deep DevOps knowledge, but how data moves, how services interact, how reliability and latency matter. Because that is what helps you build systems. And last but not the least, math intuition, all right? Understanding loss functions, optimization, overfitting. Enough to understand why models behave the way they do. You don't have to turn into a mathematician. If you can handle these three, you're ready for AI engineering. Now, what does the learning path actually look like in 2026? First step, you learn classical machine learning. Start here because it builds your mental models. Regression, classification, decision trees, model evaluation, the fundamentals that transfer everywhere. Step 2, unsupervised learning, clustering and dimensionality reduction. This is where you learn how AI finds structure without labels. Step 3, deep learning, neural networks, training loops and architectures for vision and sequence tasks. You don't need to invent new models, just understand how they behave. Step 4, NLP and large language models. This is where most real-world AI engineering happens today, because it is here that you learn embeddings, tokenization, vector databases, retrieval augmented generation, function calling, prompt design, and agent workflows, and a whole lot more. This is the backbone of modern AI systems. Step 5, infrastructure and deployment. This is the step that separates hobbyists from professionals, because you need to understand Docker, cloud basics, working with APIs and microservices, monitoring and logging, guardrails and safety, cost and latency management. Of course, human in the loop review flows, and that is where your AI becomes a product. Then we learn tools. With the right mindset, you don't need to master every framework. The winning strategy is T-shaped learning. Go broad enough to understand the field, then go deep in one area. It could be NLP or vision infrastructure or optimization, or AI product engineering. Your specialization will emerge naturally as you build. Projects, the only thing that actually gets you hired. Tutorials may give you familiarity, but projects demonstrate capability and build credibility. Start small, something like classifiers, recommenders, simple LLM chat apps, or even a retrieval-based Q&A application. Then move to system-level builds like a full RAG pipeline or a multi-agent flow if you're feeling a little up to the challenge, or a production-style AI assistant with monitoring and guardrails. Whatever you build, the document will tell. Alright, so clear README sections, architecture diagrams, evaluation metrics, failure modes, and improvements. The more detail, the better. Good documentation often matters more than the project itself, and the devil is in the details. The career reality in 2026 is that AI is now embedded in every industry. Whether it's manufacturing, finance, healthcare, logistics, education, and all the others too long to list in this video. Every company needs a system that works, not flashy demos. They need reliability, security, and cost-efficient systems. And that is why AI engineers are in demand. Salaries obviously vary region by region, company to company, but the opportunity is for real. If you can build, deploy, evaluate, and maintain AI systems at scale. And the honest truth is, the journey is not easy. You will feel confused. You may even feel that this is not for you. You may question this decision, and that's normal. The important thing is not to give up. Consistency over intensity. The people who succeed aren't the fastest. They are the ones who stay consistent and keep building. You don't need a degree. You don't need to know everything. You just need focus, patience, and perseverance to work through the complexity. If you follow the roadmap I just shared, becoming an AI engineer in 2026 is not only possible, it is achievable. Let me know where you are in your AI journey, and I'll see you in the next video.